There are some key trig formula to remember. We've already seen the basic trig formula, sine, cos and tan. When we've got 1 on tan theta, we call that cotangent, or abbreviated to cot theta. 1 on sine theta is equal to cosecant or cosec theta, and 1 over cos theta is equal to sec theta or secant theta. So we've now got cot, cosec and sec, and they're just 1 over the originals there. We've already come across the Pythagorean identity. And the Pythagorean identity says that for any angle theta, sine squared theta plus cos squared theta is equal to 1. And there's a nice neat little proof for that. We've got a right angle triangle. We've got A, B, C, and this is my angle theta. You know that the sine of theta is equal to B over C. And if we multiply both sides by C, we get C sine theta equals B. Likewise, the cos of theta is equal to A over C. So C cos theta is equal to A. And by Pythagoras, we know that A squared plus B squared equals C squared, just Pythagoras' theorem. Now instead of A, we can put C cos squared theta. Now it'll be C squared cos squared theta because it's A squared, plus now B squared, B is C sine, so it'll be C squared sine squared theta is equal to C squared. And if I divide right through by C squared, that will give us, now when I divide right through, everything over C squared, the C squareds will go there, and I get cos squared theta plus sine squared theta, and when I divide this by C squared, I get equal to 1. So that's the Pythagorean identity. From the Pythagorean identity, from this, if we divide right through by cos squared theta, and you get cos squared over cos squared, which is equal to 1, plus sine squared theta over cos squared. Sine over cos is tan, so that'll be tan squared theta equals now 1 over cos squared theta will be, and we've already seen that 1 on cos is equal to sec, so that'll be sec squared theta. If we divide right through by sine squared theta, so we're dividing this up here by sine squared theta, we get cos over sine, which is equal to cot, so we get cot squared theta, dividing by sine squared, so that'll be plus 1, equals 1 over sine. 1 over sine is cosec, so it'll be cosec squared theta. So really you only need to remember this one, the Pythagorean identity, and then just remember to get these two here. We divide by either sine squared or cos squared. So these are probably ones you don't need to remember, but you need to know how to get from there down to there. Another one is that the sine of an angle equals the cos of its complement. Now, complementary angles add up to 90. If we go here, we've got theta, we've got alpha, we've got A, B and C. From this diagram here, we know sine of theta is equal to, sine of theta is equal to B on C, and the cos of alpha, cos of that angle, is also equal to B on C. but we know that theta plus alpha, because that's 90, must add up to 90 degrees. So another way to write this algebraically is that the sine of alpha equals the cos of 90 minus alpha, or if you're working in radians, pi on 2 minus alpha. Okay, so the sine of an angle equals the cos of its complement. Sine of minus a from our unit circle and CAST, that's in the fourth quadrant. So the sine of minus a is, we know the answer is negative, so it'll be minus sine a, and the cos of minus a is equal to the cos of a, because in the fourth quadrant, minus a is in the fourth quadrant, so these angles, angle A will be down here, and because it's negative, we're going, this clockwise is the negative direction for an angle, anti-clockwise is the positive. So minus A in the fourth quadrant, it's like 360 minus A, or 2 pi minus A, so it's in this quadrant here, and that's just going to be equal to minus sine A, because sine is negative here, but cos is positive here. We've got CAST. Cos is positive, all are positive, sine is positive, tan is positive. Then we've got, so there's another one to remember, we've got the sine of A plus B equals sine A, you may not have come across this one before, cos B plus cos A, you just switch those around now, cos A sine B, and the cos of A plus B equals cos A cos B. And instead of a plus, it's a minus, sine A sine B. So there's one to remember. From that, we can work out if A equals B. So I can put, so if we call that equation 1, that equation 2, equation 1. So if A is equal to B, we get sine of A plus A, which is sine A plus A is 2A, equals sine A cos B, sorry, cos A. So we're making A equal to B. So everywhere B, we're going to write an A, plus cos A sine, now instead of that B, I'll write an A, sine A cos A, sine A cos A. So that'll be equal to 2 sine A cos A. And if we put A equal B in the second equation, we get the cos of 2A equals cos A times cos A, which is equal to cos squared A minus, and we're making A equal to B, so we'll get sine squared A. And you can rearrange these to get other ones as well, but we'll leave it at that. So you've got sine 2A equals 2 sine A cos A. Cos of 2A is cos squared A minus sine squared A. So let's just go through. This is one you need to know. This one here also. So we'll just write sine 2A there. So those two we need to memorise, being able to get. We know that these two here, these two here need to be committed to memory, and we also know that the Pythagorean identity up here, and then to be able to develop those. And then the last one is that the sine of an angle equals the cos of its complement. All right, so there's some key trig formula that you need to remember. 1, 2, 3, 4, 5.